Welcome everyone to today's lesson over absolute value equations and inequalities. So I'm going to work 3 examples, one of each, then explain the difference in the way the solutions are written and what they mean, and also try to offer you a memorization technique to help to keep these 3 versions of absolute value solving separated. So let me convert over to my document camera so you can see the paper. And you can see the 3 examples. So this is the first example is an absolute value equation with the equal sign. The second is the absolute value inequality with a less than symbol. And the third one is the absolute value inequality with a greater than symbol. These will all be worked differently, and these solutions will all be different. An equation will usually have like 2 solutions, whereas your absolute value inequalities will have numerous solutions, which we will write in interval notation. So I'm going to use a piece of paper and I'm going to turn it landscape to ensure that I can get all 3 of them side by side so we can make comparisons in these 3 examples. All right, so I'm going to begin with the equation, and I'm going to actually change the variable to x instead of a. The first thing I want to do in solving is I want to get the absolute value information isolated, nothing around it. So there's a -1 adjacent to it, so I'm going to add 1 to each side to move it to the opposite side of this equation. Now my absolute value information is isolated. At this point, to incorporate the absolute value, I'm going to branch into 2 equations. One of the 2 equations will be identical, but the absolute value symbol has been removed. And the other will be this removing the absolute value symbol, but making the right side of this equation negative. So if there were more than 1 term on this side, I'd have to change the sign on every term on the right side of the equation. Now I have incorporated the absolute value symbol. It is no longer in the equation. So solving at this point is not very difficult. I just subtract the 3 and I come up with my 2 solutions. Now it is common when you have just a couple of solutions to write them in set notation, in which you list them with a comma between the solutions. So again, we only had 2 solutions to the absolute value equation. Now I'm going to change colors as I move to the absolute value inequality with the less than symbol. Actually less than or equal to. So with the less than symbol solving, we still continue with the same process of making certain we isolate the absolute value information by adding the 1 to each side of the inequality. Now at this point, in order to absorb or incorporate the absolute value symbolism, then I'm going to convert this to a compound inequality. So I write this as x plus 3 less than or equal to 7, but then on the left side I make the negative of the 7 or the negative of the terms on the right side of the inequality. This absorbed the absolute value symbol. So now we just have a compound inequality, or sometimes this is referred to as a string inequality, and I'm going to subtract 3 in all regions and get -10 less than or equal to x less than or equal to 4. So this is the solution written as an inequality. Actually, it's numerous solutions. Any number between -10 and 4, including those -10 and 4 numbers, will be a solution to this original absolute value inequality. So before I go into interval notation, I will show you all of these solutions on a number line. When you have a compound inequality, we often call this betweenness. All of your solutions are between the -10 and the 4. So we draw a bar over all numbers between -10 and 4. The less than or equal to means that you include the -10 and the 4 as solutions. So I use square brackets. So this is called a graphical representation of all of the solutions. Now really, they're going to want, or most instructors and textbooks want an interval as your answer. So interval notation is to take the leftmost solution value, which is a -10, comma, the rightmost solution value, which is 4, with a comma between them, and then the square brackets to indicate you use the -10 and the 4 as solutions. So these are your numerous solutions written in interval notation. Now the third example of solving with this absolute value is the absolute value inequality with the greater than symbol. So again, I'm going to change colors and I'm going to go with green. Now the greater than symbol is going to produce a very different interval of solutions. So I'm going to start as I've done in both of these other examples, in which I move the 1 to the other side by adding it. And now, to incorporate or absorb the absolute value, I branch into 2 branches, kind of like I branched in the equation. And on the right side, I write it just as it was given, but removing the absolute value. And the left side is a 2-part change. I reverse the direction of the inequality, and I change the sign of the right side of the inequality, making the 7 negative. Again, the absolute value is no longer involved in the solving process. I've incorporated it in the process of making these 2 branches. So now when I solve by subtracting the 3, I get x less than or equal to -10, or x greater than or equal to 4. So there's an infinite number of solutions in the left inequality and a different set of infinite solutions in the right inequality. So let's take a look at a graphical representation of all of these solutions. If I'm looking at values less than -10 or to the left of -10, I would graph that by putting a bar to the left toward -infinity, to the left of -10, and greater than or equal to 4 would be a bar to the right of 4. So any number between 4 and positive infinity would satisfy this original greater than absolute value inequality. And any number to the left of -10 would also work in that original absolute value inequality. So I have solutions on the left and solutions on the right. This is going to result in 2 intervals. So on the left bar, I'm headed out toward -infinity. So this bar represents solutions between -infinity and -10. The right bar represents solutions between 4 and positive infinity. So I'm going from 4 to positive infinity. Now remember, infinity is not a number, so you can never put a square bracket on infinities. But you can put the square brackets on the 4 and -10, which indicate they are solutions because of the equality portion of the inequality. So we normally put a union symbol to indicate solutions are in both of these intervals. So this is your interval notation when you have the greater than absolute value inequality. So you can see the 3 examples here. An equation has a couple of solutions in set notation. The 2 inequalities have interval notation answers to represent their infinite number of solutions, but with the less than symbol, you usually just get 1 interval representing betweenness, and with the greater than symbol, you will often get 2 intervals of solutions. Now, students sometimes have difficulty understanding why you have 1 interval for the less than symbol and 2 intervals for the greater than symbol. So sometimes I try to explain this using a campfire scenario. So less than means close together, betweenness. So I try to visualize something of a campfire right in the middle of the interval of solutions. So if I have a campfire right in the middle of the interval of solutions, and let me try to just briefly sketch a campfire here for you to kind of help you to remember this. If I have a campfire right in the middle of this interval, then I want to be close to the campfire. Between this, I'm closed in to this small region. Everybody wants to be close to the warm campfire to stay warm. So we're close together, and so we have one interval. Everybody is within, say, if you looked up here, you could say everybody needs to be less than or equal to 7 feet from the campfire, within 7 feet on each side. Now, in the greater than situation, let's say in the middle we still have a campfire, but this time instead of maybe roasting marshmallows, suppose someone came in with a handful of fireworks, or maybe even worse, they came in with some dynamite. And they threw that dynamite into the fire. Well, in this case, you would want to scatter and get as far away from the fire as possible. So you would want to be greater than or equal to something like 7 feet away from the fire if there was some explosive going off in the middle. So you scatter. So when you scatter, you have two sets of solutions that are far away from the center point, which is why you would write it as two intervals with the union symbol in between them. So I'm not sure if that helps the campfire situation to help you remember why the greater than symbol results in two intervals versus the less than symbol normally results in one. But hopefully that will give you a little bit of a memorization technique to help you to understand the difference in the two. So again, all three on this one piece of paper in different colors to make certain you separate the way you work them and also the way the solutions are written. Thank you for staying through on this long video, and I sincerely hope this helps you through absolute value equations and inequalities.